In this demonstration, I'll show you how to create a sine equation when given the curve. So the first thing that you want to write out is the skeleton of a sine equation. Skeleton looks like this. Pretty much the template that you're going to use, where you have your A, B, and C value. The next thing that you want to find out is the A value, which represents the amplitude. And since this wave oscillates between 2 and -2, your A value will be 2. That's what represents your A, the amplitude. So let's plug that in, and we end up with the following. B and C are significant. B is significant because it relates to the period. C is significant because it relates to the phase shift. Notice how this sine wave doesn't start at 0 and 0, so obviously it has been shifted. Let's first find out the period. To find out the period, you have to look for the start and stop site of the wave. Notice how it starts here and it ends here. The range from here to here is the period. Now, how do we find the range? Well, all you have to do is subtract this number from this number. So let's do that. 5 pi over 6 minus pi over 6 is equal to 4 pi over 6, which is also equal to 2 pi over 3. That is your period. Now, of course, B does not represent the period, but you can find your B value by using this number. The formula for period when in radians, and since there's a pi there, we can assume that this equation will be configured in radians, is the following. Here's the formula. Period is equal to 2 pi over B. We have our period. So let's replace this PER with 2 pi over 3. So we have this equality here, and we have to solve for B. If you just observe carefully, you'll notice that 2 pi over 3 is equal to, therefore, it has to be 3. Okay? No need for any mathematics, just observations. So our B value is 3. What I'll do next is substitute that into my growing equation. 3x plus c. To find your c, which is correlated to the phase shift, you have to observe the wave that has been given. How much normally a sine curve starts right here, and it makes its way up, it goes down, and so on. How much has this point right here shifted? First of all, it's shifted to the right, so our phase shift has to be positive. Secondly, we can find out the distance simply by subtracting this number from 0, which would equal to pi over 6. So our phase shift, simply by observing, is pi over 6. Does that mean we can replace c with pi over 6? Absolutely not, because c and the phase shift are related. And the way they're related is with this formula. PS, which represents phase shift, is equal to -c over b. Our phase shift, which we just determined to be pi over 6, is equal, therefore, to -c over your b value, which was right there. Now what we have to do is solve for c. The way we do that is, well, you can do it anyway. Well, what I like to do is I like to cross multiply and then isolate for c. 3 times pi is 3 pi, and 6 times -c is -6c. Divide both sides now by -6. We end up with c is equal to -pi over 2 And there you have it. That is your C value. So what I'll do next is replace this in my growing equation, which I'll take over here. Y is equal to 2 sine 3x minus pi over 2. There you have it. That equation there represents the wave you see in blue. If you have any questions related to this, use our website at biology-forums.com. If you have any homework questions, feel free to use that website as well. See you soon.